Let us learn another multiple choice question from electrostatics. Here there are four systems of charges are given. In each system there are two charges with a different sign, with a different magnitude and separated by different distances. Let us go for the question now. Rank the electrostatic potential energy for the given system of charges in increasing order. There are four options here, option A, option B, option C, and option D. So let us know what is the basic formula behind it. That is the subject here, the path, the epsilon equals K times Q prime by R. This is what a simple formula for potential energy of system of two charges. Now we have to work on this formula for each system. So in the first system, the product of charges is minus Q square. Let us find what is the potential energy for the first system, epsilon 1 equal to minus K Q square by R. Okay. Let us go for the second system. Here, minus Q into minus Q. That will become plus Q square. So, the potential energy of the system of second system is K Q square by R. Let us go for the third one. Here, when you multiply the two charges, you get 2Q square in the numerator. There is no change in the denominators. For the last three cases, we didn't have any change in the distance. So, epsilon 3 equal to K times 2Q square by R. Let us go for the fourth system where the distance has been changed from R to 2R. So, we have to calculate accordingly. So, epsilon 4 equal to minus K 2Q square, because we are multiplying Q into minus 2Q. So the numerator will get minus 2Q square and the denominator will get 2R. The 2 cancel, we'll get epsilon 4 equals minus KQ square by R. Now we have to go with comparing each quantity. So let us start with the first one. Here we take this is minus X. And epsilon 2 become plus X, and epsilon 3 become 2X, and epsilon 4 become, it's similar to epsilon 1. So it becomes minus X. So here the negative value is the least. In that 1 and 4 have the same potential energy. So the first option, 1 and 4, are having the same potential energy. You don't have that choice in other three cases. So definitely it's going to be the option A. So anyhow, let us check whether it is less than the second system. Of course, it is less than the second system, and the second system potential energy is less than the third system. Right, everything is going good. So the right option here is option A. One, potential energy of the first system equals potential energy of the fourth system, which is less than potential energy of the second system, which is less than potential energy of the third system. Right. Let us learn the subject now. The subject is very simple here. There are charges here. The source charge. The source charge is Q, right? And the test charge is brought from R to P, right? By doing a small work. We call it as a del W. That del W will be stored in the system as the potential energy as del U. So now let us go for the theory part of this particular theory. The difference in potential energy del U is defined as the work done to bring a test charge Q prime from the point R to P at a point where the electric field due to the charge Q is E. Very simple idea. So let us go with UP minus UR. Potential energy at P minus potential energy R will be the work done. W, that will be the change in potential energy here, del U. So let us find del U equal to integration R to P F external dot dr vector. This is the force given by the external energy, which is equal and opposite to the force given by the system. That is the Coulomb force. So we replace F external by minus F vector Coulomb dot dr vector. Now we will be replacing the Coulomb force as Q prime into E vector. Right? Okay, good. Dot dr vector. Now let us bring this E vector here. What is E vector? The the electric field intensity at a point due to point charge. The formula for E vector here is 1 by 4 pi epsilon naught Q by R square into dr. So after integration, we will be getting del U Actually, it is del U, that will be 1 by 4 pi epsilon naught q prime by r. This is the potential energy of the system. This energy exists as long as the external energy is doing the work. If there is no external energy, there is no potential energy, because this force is a conservative force. So epsilon equal to k times q prime by r. Learn problems, learn physics, like, comment, share, subscribe my channel. Thank you.